So the exercises for 2.7 start with asking what the inverse is informally and then to verify them. So if we have this function and it says to verify whatever the inverse is informally, if you have values, it doesn't matter which ones we pick, I can just pick 1, 2, and 3. If I plug it in, I get 6, then 12, then 18. The goal is that for my inverse is that I'm going to get a function that takes 6, 12, and 18 and maps them back to 1, 2, and 3. So what I need to do is I need to figure out what that inverse would be. Well, the opposite informally would be to divide by 6. So this inverse function is to divide by 6. And the way that you check is you plug or compose the inverse and see what happens. So I plug this inverse in to the original, and I get 6 times x over 6, and I get the identity function because the 6's cancel out. Then I plug the inverse and compose that with the original function, and I get 6x over 6, and I'm still left with the identity function. So evaluating it both ways leaves me with the identity function. So for exercise 19, it says to verify that these two functions are actually inverse functions. So what I'm going to do is I'm going to compose them both with each other. So I'm going to compose this one into x. So what happens is, instead I'm going to get negative 7 halves. Instead of x, I'm going to get negative 2x plus 6 over 7 minus 3. And I'll see what happens here. Well, I have to distribute this, and this is really hard to look at from the sense that I need to multiply this all out. So I'm going to take this negative 7 and multiply it all through. And then I'm going to take this 2 and multiply it. Because when you're multiplying fractions, you multiply straight across. But when you have this, you're multiplying using a distributive property. So a negative times a negative is actually just going to be positive. So I'm going to get 14x plus 42 over 14 minus 3. So I just distributed the 7 and then multiplied the 2 by 7. All of this is divisible by 14, so that cancels out. This is left with 3, so I have x plus 3 minus 3. You're left with just x. Now I'm going to do the exact opposite. I'm going to compose the f of x into g of x. So what I have is negative 2 times negative 7 halves x minus 3 plus 6 all over 7. So I'm going to distribute this negative 7, or excuse me, this negative 2 to these things in the parentheses, and I'm left with, this negative should be out here, I'm left with a negative 7x with a negative out in the front of the parentheses, fraction, minus 6 plus 6. So again, this negative is way out in the front of this fraction. And I didn't put it out there. I put it in front of the 2. But it should be out in front of the fraction. So it should be out here. So 2 times a negative 7 halves is negative 7. 2 times a negative 3 is negative 6. Then the plus 6 all over 7. These cancel out. We have 7 over 7. They cancel out. We have a negative x with a negative in front, so it's a negative x with another negative, so they cancel out. We're left with just x. Now for exercise 25, it says that they are to show that these are inverses algebraically and graphically. So what I'm just going to do is I'm going to show you algebraically. So for 25, we have 7x plus 1, and I'll try not to be as messy with this one as the last one. So what I need to do is I need to compose the first one. So I'm going to take this function and plug it in here. So I have 7 times x minus 1 over 7 plus 1. These 7's cancel out because you're multiplying and dividing by 7. So what I'm left with is x minus 1 plus 1. So I'm left with just x. Now I'm going to do the exact opposite. I'm going to compose g of f of x. So what I'm going to get is 7x plus 1 minus 1 all over 7. So I plugged this in for x right here. So I took this expression and I plugged it in for x right there. The 1's cancel out, so I'm left with 7x over 7. They cancel out, you're left with x. Now I'm going to go to exercise 63. It says determine whether the function has an inverse function. If it does, find the inverse. Well, x to the 4th is an even function. And what this looks like is kind of like a parabola. And if you look at this, if I plug in -1, I get +1. If I plug in 1, I get +1 also. So this fails the horizontal line test. So this is not 1-to-1. So it doesn't have an inverse. So it doesn't have an inverse function. So let's take a look at this next one, checkpoint number 69. So now they get a little trickier here. They say, well, x has to be greater than or equal to -3. Now this is a parabola that gets shifted a specific number of units. It actually gets shifted to the left 3 units. So it actually starts here. So that's what it looks like. So I can't use anything to the right of, or excuse me, to the left of -3. So this is what it looks like. This passes the horizontal line test. And because it passes the horizontal line test, it is 1-to-1. It has an inverse. And then it says to find it. So we have an inverse for this. So we're going to find it. So the way that we do that is I replace x and y. And the way that I do this now is I solve it for y. So I take the square root of both sides. I get the square root of x equals y minus 3. If I add 3 to both sides, I get y equals the square root of x plus 3. And there is my inverse function. So the inverse is equal to the square root of x plus 3.